Section 9.5 continued. Simplifying complex fraction notes. All right, so we're going to write some stuff at the top of our paper before we begin. So these are the steps to simplifying complex fractions. So a fraction divided by a fraction is a complex fraction, and ours are going to have some addition and subtraction thrown in there that we just learned. So the first thing you're going to want to do is find the LCD of all the denominators. After you do that, the second step is going to be multiply the numerator and denominator by the least common denominator. Oops. So by the least common denominator. And then simplify. Now, really, there's going to be two different ways that we can simplify these problems. I will show you both ways, but usually students tend to like one way more than the other. But like I said, I will show you both of them. So if I look at example 1, I have a fraction divided by a fraction. So for this one, I know that this is my numerator and this is all y is just in my denominator. So in this case, y is really over 1, even though it's not written. And we've already talked about when you have of number fraction divided by fraction, you multiply by the reciprocal, and it has to be one fraction in order to do this. So you could write 1 over x divided by y, which would be equal to 1 over x times 1 over y, which is going to give me 1 over xy. So that would be my solution. So those are easy complex fractions. Now we're going to get into more difficult ones. Like if you look at number 2, this problem's a lot harder because I have this right here, which is 2 terms. I have a fraction divided by 2 terms, and because of that, I can't go ahead and divide a fraction by a fraction because I need to combine my denominator. Now, there's a couple ways that you can do that. So like I said, I'm going to show you both ways. The first thing you can do is look for the least common denominator between all denominators. So if I look here, I have 1 over 1 and then 3 over 1 in my numerator. And usually I know what's in my numerator because it's separated by a longer division symbol, like right here. So for this, my LCD between 2y and 1 would be 2y. That means I'm going to take that LCD and multiply both my numerator and denominator by it. Because remember, this is like multiplying by 1, so it doesn't change my equation. Now when I do this, I'm going to take that and multiply this first, so I get 6y here, and then I'm going to take this 2y and I have to multiply it by each of these terms, so 2y times the 1 and then 2y times this term here. So I have in my denominator 2y minus, and this would be 2y over 2y. So now I can simplify 2y over 2y, I know is really equal to 1. So I get 6y over 2y minus 1. And then if you look here, now we just have one fraction, and I can't simplify anything further. I can't cross off those y's because this is being multiplied, but this y is attached to that 1. So that means that since it does not simplify and I can't factor anything out, that this would be my solution. So that's one way to do this problem. The other way that I can do this problem is by working with the numerator and denominator separately. So I'm going to do that as well. So I'm going to do that off to the side over here. I have 3 over 1 minus 1 over 2y. So if we ignore the numerator because it's only one term, it doesn't have to be combined, and just look at the denominator, I know that this is 1 over 1, and I know before, because we already said that my LCD was 2y, so I would multiply this by 2y over 2y. So remember, just looking at your denominator, when you do that, you would end up with in your numerator 3 over, and we have 2y over 2y minus 1 over 2y. Now that I have a common denominator, I can add my numerator over that common denominator. So this would be 3, and then we have 2y here, and then 2y minus 1. So now I have a number divided by a fraction, so that means I'm going to have to flip that second fraction and multiply by the reciprocal. So I have 3 over 1, and then I'm going to multiply, I'm going to flip this right here. So 2y over 2y minus 1. So numerator times numerator gives me 6y over, and then denominator times denominator, so all of this times 1 is just the same thing, so 2y minus 1. And again, we can't simplify anything, so this would be my solutions. Notice that we got the same answer. It looks like in this case, the first way to do it was a lot shorter than the second way. Sometimes that will be the case, and sometimes that won't be the case. So it just depends on how many terms you're working with. So in this case, it was a lot easier to do the first way than it was the second. The second way, I just worked with the denominator, got a common denominator, and then multiplied by the reciprocal. So let's go ahead and go look at number 3. And I'll do both ways again for number 3 just so that you can see. So the first thing I want to do is look for my least common denominator between all denominators. So 5's over 1 and 2's over 1, even though it's not written, it helps me to write it in. Now, what's common between x minus 2, 1, and 1 and x minus 2? Well, I know it's going to be 1 times x minus 2, so just x minus 2. That means I'm going to multiply the numerator and the denominator by my LCD of all my denominators. When I do that, I end up with, and I'm going to distribute this to each of my terms. So this is where it gets kind of tricky. So I have to do this times this here. So that would be 3 times x minus 2 over x minus 2 minus, and now I'm going to take this times this term here, 5 times x minus 2, and that's over 1. So you can write over 1 if you want to, but you don't have to. All divided by, and I'm going to do the same thing here. So this times this would give me 2 times x minus 2, and then this times this gives me 4 minus 4 times x minus 2 over x minus 2. Now when I do this, I can simplify some things. So I can cancel this out and this out. And the reason we do this method is because it cancels out your denominator, so you don't have to work with it when you multiply everything by the LCD. So then notice in my numerator here, I would get 3 and then minus 5 times x minus 2, and in my denominator I have 2 times x minus 2 and then minus 4. So now I need to just simplify these terms. So I need to distribute here. So we have 3 minus 5x plus 10 over, and I'm going to distribute the 2, my denominator, 2x minus 4 minus 4. This becomes negative 5x plus 13, because 10 plus 3, over 2x minus 8. I would see if I could factor anything. Like I know I can factor the denominator here. I can take out a 2 and this becomes x minus 4, but I can't factor anything in my numerator. So that's not going to really simplify it all. So this would be my solution then. So that's one way. And again, when you're doing that way, you're basically canceling out all of your denominators so that you don't have to work with a complex fraction. Now let's do the second way. So this is way number 2. So for way number 2, I'm going to rewrite the problem. Now way number 2 is different because we're going to work with the numerator and denominator separately. So like it's not the same. Okay, so it's like we're going to look at the two separately. So I'm going to cover up, I'm going to go ahead and cover up this denominator. So pretend like that's not here for right now. We're just going to do what we did before, and we're going to simplify the numerator. So in order to simplify the numerator, we want to subtract the terms, and in order to do that, we need a common denominator. So what's the least common denominator between 1 and x minus 2? X minus 2. So that means I need to multiply this by x minus 2 over x minus 2. So when I do that, I get 3 over x minus 2, and then that 5 is going to be multiplied by both of these, so minus, and don't forget that negative goes with the 5, so minus, and then we have 5x, and then 5 times 2 would be minus 10 over x minus 2. So really, we're going to have to end up distributing that negative, which we'll do in just a second. So if I come down here, I'm going to write, we have 3 and then minus 5x plus 10. I have to distribute the negative that's here to both those terms over x minus 2. And then that becomes negative 5x plus 13 over x minus 2. All right, so that was just doing the numerator part, and I simplified that into one fraction. Then I would have to look at the denominator part and simplify that into one fraction. So I'm going to ignore this other part that we have here. So just ignore what you have in the numerator here. And so ignore like that whole piece up there. So we're just going to go ahead and look at what is in my denominator. So now if and I'm going to go ahead and move this as well. Move that down here and we'll get back to that. So now if I just look at my denominator and I want to do the same thing. In order to make this one fraction, I have to get a common denominator. So that means I need to multiply this by x minus 2 over x minus 2. When I do that, I get 2 times x minus 2 over x minus 2 minus 4 over x minus 2. Now that you have a common denominator, you can combine things together. So this gives me, I'm going to distribute here, so 2x minus 4, and then we have minus 4 here, so minus 4 over x minus 2, because that's my common denominator. And then this would be equal to 2x minus 8 over x minus 2. Well, I'm not done. So I just worked with my numerator and denominator separately. So now I have to put the two together. So I'm going to go ahead and move this. Let's just move that out of the way. I'm going to put it over here. So now I want to work with the numerator and denominator. So this was my denominator that I just did. And this part right here was the numerator. So now remember, I'm really dividing these two fractions. So I have to take those two answers and divide them. So I'm going to move my page down so we can do this. So I really have 2x minus 8, or actually, sorry, 5x, negative 5x plus 13 over x minus 2 in my numerator, and that's all being divided by 2x minus 8 over x minus 2. And then we've solved these before. So how do you divide a fraction by a fraction? You multiply by the reciprocal of the second term. So negative 5x plus 13 over x minus 2 times, and then I would get x minus 2 over 2x minus 8. And then notice that you look for a common factor since this is multiplication here. Now I can cancel these out, and that becomes equal to negative 5x plus 13 over 2x minus 8, which is the same thing as what we got right here. But that way took a lot longer than it took me to do the first way. So you can do either of the two ways. It's fine, but like I said, sometimes one way will take you more time to do than another way. So again, just to look at the two different ways, the first way we took the least common denominator of both my numerator and denominator and multiplied the numerator and denominator by that to cancel out my denominator. So that's what we did first. And then we got this. The second way, we just looked at the numerator and denominator separately. So first we did the numerator and ignored this part and then got one fraction there. And then we ignored the numerator and got one fraction here. And then after we did all that, we ended up combining them together into one big fraction to multiply by the reciprocal and simplify. So sometimes that's easier process to do and sometimes it's not. You just have to kind of choose which one that you like to do better. So let's go ahead and do number 4 together. So I'm going to move this out of the way. Just move this down here. I need to erase this so that we have room to write, but of course you're going to want to make sure that you keep all the work up here. So I'm only erasing again so that I have room to do this problem. So you might need a separate sheet of paper to write some of this on too, because I know can be a lot if you write big like I do. Okay. So I just got rid of that. All right, so let's look at this next problem. Let's do the same thing. So I'll do both ways again. So for this next problem, we have 1 over x, and then this would be like over 1, and this would be over 1. So my LCD between all of my denominators would be, now just you have 1x here and 1y, so it's going to be xy. So when I do that, I have to multiply xy by all of my terms in my numerator, so this times this and this, and then the same thing by all of your terms down here. So that's going to give me xy times 1 is xy over x plus 3xy, and I can write that over 1 if I want to, but it's not necessary, over 5xy over y plus 4, and then this would be just xy. Then I would simplify. We did that so we can cancel this out, and this cancels out. And again, the only reason those cancel out is because there's no addition or subtraction. You cannot do that if it was plus 5x plus y, or x plus y over x. That would not cancel out. It's only because it's multiplication and division. So now that I did that, then I can get in my numerator y plus 3xy over my denominator, which would be 5x plus 4xy. And I can actually factor out y in my numerator. So I'm going to factor, see if I can simplify anything. So this would be y times 1 plus 3x over, and then my denominator I would get x times 5 plus 4, not x, yeah, plus 4y. So that doesn't cancel anything out. So because that nothing cancels out there, I'm going to leave this as my answer. You could leave your answer in factored form. It's technically not simplified because simplified means you have no parentheses, but I will accept it from you guys now since we're just learning this. So let's try the other way. So for the other way, I have 1 over x plus 3 all divided by, and then we'd have the next part. So let's just look at the numerator first. So just looking at the numerator, if I want to simplify this into one fraction, which is what I have to do first for the second way, I need to multiply this by x over x. So when I do that, I get 1 over x, whoops. So this would be 1 over x plus 3x over x, which would be 1 plus 3x over x. And then I'm going to do my denominator now. So my denominator is 5 over y plus 4. So I need to multiply this by y over y because this is over 1. That would give me my common denominator. So that's equal to 5 over y plus 4y over y. Now I have my common denominator. So that would give me 5 plus 4y. Whoops, 4. So 5 plus 4y over y. And remember, these two are being divided. So now I have a fraction divided by a fraction. I would multiply by the reciprocal. So I'm going to bring all that down here. So then this would be 1 plus 3x over x, and then times y, I'm multiplying by the reciprocal, over 5 plus 4y. And then numerator times numerator, denominator times denominator. So this would be y times 1 plus 3x over x times 5 plus 4y. Notice that this right here is the same as the factored form that we had. And then you could multiply that back through since nothing simplifies. So that would be y plus 3xy over 5x plus 4xy. And notice that this is the same as what we did over here. It just was another method. We first worked with the numerator, got it as a fraction, then we did the denominator, got that as a fraction, multiply by the reciprocal, and then simplify. Whereas over here, for the first way, we eliminated our denominators by multiplying everything by the LCD, and then we simplified. So I would pause the video here and see if you can do number 5 on your own, and then unpause the video, and then I'm going to work through the problem. All right, so I'm going to erase this here. You want to keep that on your paper, of course, but I'm erasing it so that I can do the problem. Okay. So I'm going to do the first way first. So for this one, and you can choose any method, the LCD between every denominator would be, we have an x here, so x, there's no other x's. We have an x plus 1 and an x minus 1. So that's my LCD between everything. So that's what I'm going to multiply the numerator and denominator by. So in my numerator, that means all of this gets multiplied by this first term here. So we have x minus 2 over x, and that's all going to be multiplied by x times, oops, and then we have minus 2 over x plus 1. So that's going to also be multiplied by, and then in my denominator, so this is all divided by, and then minus, and then the next thing that I would do is I would start to cancel and simplify things. So since this x is being multiplied here and this is not added or subtracted anything, we can cross those off. So those cancel out. X plus 1 and x plus 1 cancels out here. X minus 1, x minus 1, and x plus 1, and x plus 1. And again, the reason we did that was so that we don't have to work with any denominators anymore. So when I do that, I now get x minus 2 times x plus 1 times x minus 1 minus 2x times x minus 1 in my numerator, all over my denominator, which would be 3x times x plus 1 minus x times x minus 1. And now I need to simplify this. So because I have binomials times binomials, that means I need to FOIL them out. So I'm going to do the numerator first. So I'm going to FOIL, I'm doing this work off to the side, x minus 2 times, this is off to the side here. So we have, I'm going to FOIL this one out. So x squared plus x minus 2x minus 2. So when I combine that, I get x squared minus x minus 2. And this needs to be multiplied by x minus 1. So I'm going to do the box method so that you can just practice that. You don't have to. You could also do FOIL in this one. This would be x cubed minus x squared minus 2x minus x squared x and then 2. So then I get x cubed minus 2x squared minus x plus 2. So that's going to be the first part. So I have here x cubed minus 2x minus x plus 2. So I just did this whole FOIL part out right there. So now I got to distribute the negative 2x to each term. So minus 2x and then minus 2 times negative 1 because positive 2 x over, and now I need to distribute my denominator. So 3x squared plus 3x, and then distribute the negative x, so minus x squared plus x. And now I just need to combine terms. So here, there's no other terms that go with x cubed. And then we have negative 2x, negative x, negative 2x. So that gives me minus 4, and that should have been, I think, squared. I forgot the squared there, so that's my fault. So this is 2x squared, and this is squared. Because this was squared right here, I just didn't write it in. Sorry about that. So make sure to put that in. So minus, so that's not, this one's not a like term. So minus 4x squared, and then we have negative x and positive 2x, which is going to give me positive x, and then plus 2 over, and then in my denominator I have 3x squared minus x squared, which would give me 2x squared, and then I got 3x plus x, which would be plus 4x. So I'm not done because I want to see if I can factor this all to simplify anything now that I've combined everything into one fraction. Most of the time you can't, but sometimes we can. So this would be factored by grouping in my numerator, x cubed minus 4x squared plus x plus 2. So if I group these two and these two together, I would get x squared times x minus 4, and then this would be, you can't factor anything out, so plus 1 times x plus 2. Since these are not the same, I can't do factor by grouping, so that's not going to factor. I'm going to erase that. My denominator can factor, so my denominator can factor into, whoops. So my denominator can factor into 2x times x plus 4. So you could write your denominator over that. This would be our solution. Or right now, I would also take x cubed minus 4x squared plus x plus 2 over 2x times x plus 4. If you want to leave the denominator in factored form, that's okay. But this one is actually the correct answer. You wouldn't leave it with parentheses in your solution. Now, I could also do this the second way by just looking at my numerator first by itself, and then denominator, good common denominators, make it a fraction divided by a fraction, and then after you do that, you would multiply by the reciprocal. So if you want to do that way and check it to see if you get the same thing, that's fine. If not, that's okay too. But like I said, a lot of these problems is just a lot of practice, and there's not one way that's right. You could do either of the ways, and it's just making sure your terms are correct. So make sure that you have this for class on Monday.